Picking the right project structure in software development is super important for teamwork, keeping things tidy, and making it easy to grow. There are two main ways to organize the structure of your project: layered or feature. Each has its own pros and cons, but in the end the choice really depends on what kind of project you're working on. In this video, we'll explore both options and how to pick between them. Let's start by looking at the layered approach. This is where you have multiple layers of folders, typically organized by their purpose. This ensures a separation of concerns. For example, you might have a folder for services, another one for controllers, and another for database entities. The common layers are the presentation layer, the business logic layer, and the data access layer. Within these folders, you would place files that relate to that layer. So all your business logic would go into the services folder, i.e., the business logic layer, all your database models into the entities folder, i.e. the data access layer, and all your API endpoints into the controllers folder, i.e. the presentation layer. The layered approach is a pretty common way to organize a project. Each layer has distinct responsibilities, making it easier to manage and maintain. However, there are a few problems with it. First, it can lead to over-architecting, especially for small projects. This will cause your project to feel bloated. Another disadvantage is that these layers can be tightly coupled, meaning that changing something in one layer may affect another layer. Secondly, the layered approach doesn't work well when you have cross-cutting concerns. Cross-cutting concerns are features that cut across multiple layers of the application. A good example of this is logging in a social media app. Logging should happen at every layer of the app, but where do you put the logging code? Do you put it in its own layer? That seems wrong, since a layer cannot interact with all the other layers. It can only interact with its adjacent layers, but the logging system needs to interact with every part of the code. Or do you put it in each layer? That means you have duplicate code, and when you need to make changes to the logging setup, you have to implement these changes at every layer. That's a nightmare. Nobody wants to do that. The alternative to the layered approach is the feature-based approach. This is where you have a folder for each feature of the application, and each folder contains everything needed to implement that feature. So in our social media app example, we would have a folder for posts, likes, and comments. Each of these folders would contain the business logic for that feature, as well as any controllers, database entities, and other folders needed to implement that feature. In this approach, the logging would be considered a feature. For example, the comment folder might have a model for the comment, the controller that handles the API requests for the comments, and the service that implements the business logic for the comments. The feature-based approach has a lot of advantages. For example, it results in less duplicated code because all the code for a given feature is in one place. It also makes it easier to reason about the code because you only need to know about the features that you're reworking on. And it also makes it easier to test the code because, again, all the code for a given feature is in one place. Also, it's easier to transition from a monolithic application with a feature-based structure to a microservices architecture, as each feature can be easily converted into a microservice, as all its code is in one place. However, there are a few disadvantages to the feature-based approach. For example, it can be difficult to keep the features isolated from each other. If you have a complex application with lots of features, it can be difficult to keep the code for each feature contained within its own folder. Additionally, it can be challenging to organize the code within each feature folder. And finally, it can be difficult to reuse code between features. A good trick is to create a utility folder to contain code that is used by multiple features. So let's look at some examples to see how these two approaches actually work in practice. Let us say you're recreating a web app that allows users to upload images and then share those images. You'd probably have a few different layers to your application. You'd have a layer for storing the images in a storage service like a and also to store image metadata in a database. This layer will contain files like entities and repositories for interacting with the database. A layer for your business logic. This layer will contain files like authentication SIG, and a layer for your user interface. This can be the front end or an API. It'll have components for authentication, image upload, and image sharing. If you were to use the layered approach, you would have 3 different folders, one for each of these layers. Then you would have subfolders within each of these folders for each of the different features within that layer. If you were to use the feature-based approach, you would have a folder for each of the features in your application. So you would have a folder for authentication, a folder for handling image uploads, and a folder for handling image sharing. Let's look at another example. This one is a little bit more complex. Let us say you're recreating a web app that allows users to create and manage their own websites. The users can then publish their websites to a server where they can be viewed by anyone. If you were to use the layered approach, you would have at least 3 different layers: data access, business logic, and presentation. Your data access layer would contain all of the code for storing the websites your users create. If they're files, they would be stored on a platform like a WSS3. If you're restoring the website S code as raw strings, then it'll be in a data. Your business logic layer would contain all of the code for the application logic, like authenticating your user services for users to build and validate their websites, and your UI layer would contain all of the code for the user interface. If you were to use the feature-based approach, you would have a folder for each of the features in your application. So you would have a folder for managing users, a folder for website building, and a folder for publishing the website. So now that we've looked at a few examples of how these two approaches work in practice, how do you decide which one to use? Well, there's no easy answer. It really depends on the specifics of your application. However, I can offer a few suggestions. Now, if you're diving into social media apps or mobile banking, a feature-based setup is where it's at. It lets teams work on things like user profiles or transaction histories without stepping on each other's toes. And don't forget about your team dynamics. Cross-functional teams tend to thrive in feature-based setups because they boost collaboration, while specialized teams might do better with a layered approach. Also consider how quickly you need to develop versus how much long-term support you'll need. Feature-based structures are great for fast iterations, while layered ones help keep things organized for ongoing maintenance. Weighing these factors will help you make the right choice. Sometimes, a mix of both might even be the perfect solution. One final note, don't be afraid to break your project into multiple layers. If it makes sense for your application, there's no rule saying you can only have one layer. For example, if you have a very complex application with lots of features, you might want to break it up into multiple layers. This can help make the code base more maintainable and easier to scale. Ultimately, the most important thing is to choose an approach that works for you and your team. There's no one-size-fits-all solution. Hopefully this overview was enough to get you started, and if you have any questions, please ask in the comments. We can always continue the conversation there. Thanks for watching, and I will see you next time.